All right, so on the back of these notes, we're going to talk about square roots and how to determine whether they're rational or irrational. So go ahead and turn to the back. We're going to add our own things on the back of here. Okay, so square roots are rational when they are perfect squares. And what I mean by perfect squares, I mean that when the square root gives a whole number. So if it's rational, the value of the square root will be a whole number. Okay, and so we are going to take some time and look at the square root values from 1 to 10. So on the left side of your page, just go down vertically. Square root of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and we are going to use our calculator to calculate each one of these. So if it gives you a whole number, we will just write rational next to it. If it does not give us a whole number, then we will write its decimal expansion. If it has a decimal expansion, then it's automatically an irrational number. Okay, so first thing we will do is type in the square root of 1. Remember, to type in the square root, you press second and x squared. It will give you that square root symbol. And then you will simply put in the number 1 and press enter. What is the value that we got out? We got 1. 1 is a whole number. So next to that, in all caps, we will write that it is rational. Okay, go ahead and find the value of the square root of 2. So when you calculated the square root of 2, what did it show you back? For the square root of 2, you press second and x squared. And then you will put in the value of 2. Okay, so whenever you calculate that, what happens? It gives you the exact same thing. And what that means is that it's not going to be a whole number, right? So I said, if it's not a whole number, it's automatically irrational. And all we're going to do is write the decimal expansion. How do we get that decimal expansion? Press that decimal expansion key. So it's down here at the bottom above enter, and you see the decimal expansion. We're just going to cut it off at the 4th decimal point. So we're going to write that it's equal to 1.4142, and that the 3 dots mean it just keeps going. Okay, now what about the square root of 3? Is this one rational or irrational? Irrational. How do we know? It gave me the exact same thing. That's not a whole number, is it? Okay, so now we're just going to write its decimal. So press that decimal expansion key. And so we all should be writing 1.7320 ... Go ahead and calculate the square root of 4. Is it rational or irrational? What was the answer to the square root of 4?
2.
2. Is 2 a whole number? Yes. If it is a whole number, then that means that it is rational. Yes. Okay. What about the square root of 5? Okay, so it gave us the root of 5 back, which means that it's going to be irrational. Let's look at its decimal and write it down. So that's 2.2360, and it keeps going. Go ahead and find the root of 6. So the square root of 6 gives you the same answer back, so that means that we're going to be looking at its decimal expansion, which means it's not going to be rational. So that's 2.4494, and it keeps going. And then we're going to find the value of the root of 7. It gave me back the same thing. So I'm going to look at its decimal. So that is 2.6457, and keeps going. Now what about the root of 8? Is it rational or irrational? Let's see, it gave me 2 square root 2. Is that a whole number? No, we don't have any whole numbers that have roots in them, do we? So this one is not a whole number. That means that it is irrational. So let's look at its decimal expansion. So we're going to write down 2.8284. Now what about the root of 9? It is rational because it is equal to what? It is equal to the whole number 3. So we're going to write in all caps that it is rational. So far, how many rational numbers have we found? 3. 3 of them for square roots, right? And the square root of 10, which one is that? Rational or irrational? Irrational, because when we calculate it, it gives us a square root of 10 back, which means that we're going to look at its decimal expansion, and that is 3.1622, and it keeps going. All right, now, let's talk about the patterns that we see here. The square root of 1 is 1, and the square root of 4 is 2. And then we have the square root of 9, which is 3. Okay, so looking at these 3, notice that the numbers in between for the square roots that are in between those are actually between 1 and 2 here. And then all of the values between the root of 4 and the root of 9 are all between 2 and 3. And that pattern is going to continue. So how are these whole numbers showing up, or why are they showing up? Does anybody know why? Okay, so think about this. 1 times 1 is 1. What's 2 times 2? 4. 3 times 3? 9. What would be the next whole number after 3? 4. What's 4 times 4? That means the next square root that is rational is going to be the square root of 16. That means that everything in between the square root of 10 to the square root of 16 is going to be irrational. So if we went to expand this, 11, 12, 13, 14, 15, I know that all of those numbers in between are going to be irrational numbers. What would be in my next rational square root? What comes after 4? So what's 5 squared, or 5 times 5? So the next square root that's going to be a rational number will be the square root of 25. Okay. So that's why when I say if it doesn't give you a whole number, it's going to be irrational for all square roots. That's a good rule of thumb.